Right now, around 20,000 kilometers above your head, there are 31 satellites built by the United States military, screaming through space at 14,000 kilometers an hour. And not a single one of them has any idea that you exist. They have never heard of you. They are not watching you. And yet, somehow, the phone in your pocket can pinpoint where you are standing to within a few meters. That contradiction is the whole magic of GPS. And once you see how it works, it is hard to believe it works at all. Let's kill the biggest myth first. GPS does not track you. We say it like the satellites are following us around, but it is the exact opposite. A GPS satellite is just a lighthouse. It sits up there and endlessly broadcasts one boring message over and over. Here is exactly who I am, here is exactly where I am, and here is exactly what time it is. That is it. It shouts this into space forever, to no one in particular. Your phone just listens. It never talks back. The satellite has no clue whether one phone is listening or a billion. GPS is a radio station, and you are simply tuning in. So how does listening to a lighthouse tell you where you are? With a beautifully simple trick, and one nasty hidden problem. Let's do the trick first. The satellite's message travels at the speed of light. Your phone notes the exact time it was sent, and the exact time it arrived. Multiply the tiny delay by the speed of light, and you get your distance to that satellite. Now, knowing you are 20,000 kilometers from one satellite doesn't tell you much. You could be anywhere on a giant sphere that far from it. But add a second satellite, and now you must be where those two spheres overlap. A third satellite narrows it down to basically a single point on Earth. This is called trilateration. And note, it is not triangulation. Triangulation measures angles. GPS measures distances. 3 overlapping bubbles, shrinking onto one spot. But here's the nasty hidden problem, and it is the part most explanations skip. To measure the travel time of light, your clock has to be absurdly accurate. The satellites carry atomic clocks, accurate to billionths of a second. Your phone does not. Your phone's cheap little clock is, by comparison, a pathological liar. And if your clock is off by even 1/1,000,000th of a second, your distance is wrong by 300 meters. So how does a phone with a lying clock get within a few meters? With a fourth satellite. Here's the elegant part. When you only have 3 satellites and a wrong clock, the 3 bubbles don't quite meet at one point. They miss. But there is only one possible plot correction that snaps all 4 bubbles together onto a single spot. So your phone just solves for it. The fourth satellite doesn't only locate you, it secretly fixes your phone's clock, hundreds of times a second. That is why you need 4. Now, about those atomic clocks. They are so precise that Einstein himself shows up. According to relativity, 2 strange things happen to a clock in orbit. Because the satellites are moving so fast, their clocks tick slightly slower. That is special relativity, and it loses them about 7 microseconds a day. But because they are far from Earth's gravity, way up high, their clocks tick slightly faster. That is general relativity, and it gains them about 45 microseconds a day. Add it together, and a GPS clock runs about 38 microseconds per day too fast. That sounds like nothing. But left uncorrected, that error would throw your location off by about 10 kilometers every single day. Your map would have you drifting into the ocean within hours. So engineers build the clocks to tick at deliberately the wrong speed on the ground, so that once they are in orbit, relativity speeds them up to exactly right. There is genuine Einstein baked into your phone, just so you can find a coffee shop. So if all this is bouncing off satellites 20,000 kilometers up, why does your phone find you almost instantly? Because it cheats, in a good way. Pulling the full schedule of satellite positions straight from the satellites is painfully slow, trickling in at 50 bits a second, which can take over 12 minutes. So instead, your phone grabs the data over Wi-Fi or your mobile network in a second or two, and uses nearby cell towers to make a rough first guess. This is called assisted GPS, and it is why your blue dot appears almost the moment you open the map, instead of after a 12-minute wait. And how accurate is the final result? For a normal phone, around 5 to 10 meters. In a city, tall buildings bounce the signals around and make it worse. Which is why your modern phone doesn't only use American GPS. It also quietly listens to Russia's, Europe's, and China's satellite systems, all at once, to pin you down. And the arrangement of those satellites is no accident. They are spread across 6 tilted orbital lanes, looping the planet twice a day, spaced so that from basically any open spot on Earth, at any moment, at least 4 of them are above your horizon. The whole constellation is choreographed so you are never out of range. There is always a quorum of lighthouses overhead, whether you are in Tokyo or the middle of the Pacific. And cities are GPS's worst nightmare. When you are surrounded by tall glass towers, the signals don't always arrive straight from above. They bounce off the buildings first, arriving a fraction of a second late, which fools your phone into thinking the satellite is further away than it really is. That is why your blue dot sometimes leaps across the street, or smugly insists you are inside the building next door. It is not broken. It is being lied to by reflections. So let's appreciate the full absurdity. A network of atomic clocks, launched by the military in the 1970s to guide missiles, is flying through space being constantly corrected for Einstein's relativity, broadcasting the time to no one in particular, so that the phone in your hand can silently solve 4 equations and figure out that you are, in fact, standing outside a taco truck. It is free. It is invisible. And it never, ever stops. If you just learned something genuinely useful, hit subscribe. We break down the tech you use every day.